Hello everyone, I hope all of you would be doing well. So in this video I'm going to draw a shear and moment diagram for a simply supported beam. So as you can see that the beam has a length of 6 meters and is loaded with its a uniform distributed load of 2 kilonewton per meter. So let's start the procedure for drawing the shear moment diagram. So first of all, we need to determine the support reactions at A and B, and followed by that we will take a section from point A to any point of X on the beam, and we'll make equations for moment and shear diagram. So let's start. So first of all, we should determine the first step is to determining the support reactions. So summation of moments at point A must be equal to 0. So now -2 multiplied by 6. I hope you will understand this step. So 2 by 6 plus by 2 by 6 multiplied by 3 plus by multiplied by 6 must be equal to 0. So we have got 6 by equals to 36, and therefore we have got the value of by as 6 kilonewton. And summation of forces at y direction must also be 0. So ay plus by, which has a value of 6, -2 multiplied by 6 must be equal to 0. Therefore ay also equals to 6 kilonewton. So now we are going to take a section from point A till any point there, so we call this section as AA. So step number 2 is taking a section at any point from A, from starting point. So we have taken a section of AA. This example, we have taken a section of AA. So we are going to do the process over this section. So this is the segment we have just taken from that beam. So this is the reaction of 6 kilonewtons, and this is the uniform load of 2 kilonewton per meter, and this distance is x. It means that we have taken an unknown point from A. So whatever the distance it may be, it might be 2 meters, it might be 3 meters, and whatever distance it can be. So as per laws of equilibrium, we have a load of Vx right here and have a moment at this point also. So now for determining the shear equation, we write summation of forces in y direction must be equal to 0. So we have got -Vx plus 6 kilonewtons and -2 multiplied by x, it must be equal to 0. Therefore we have got shear equation as 6 minus 2x. This is our shear diagram equation. And for moment, we have got summation of moment at point X must also be equal to 0. So we have got mx itself, since it's a reaction, internal reaction, now plus this load. So this is the quantity of the load, 2 multiplied by the x. We gave a total load multiplied by this distance. Since it is a half distance, we divide the length by 2, so x by 2 and plus 6 multiplied by x must be equal to 0. Therefore mx equals to, this is with this one, equals to minus x squared plus 6x. So this is the equation for our moment diagram. So now let's plug in the values for each point on the beam. Step number 3 is drawing the diagrams, drawing the diagram. So these are the equations. In other words, these are also the functions of for the shear and moment of this beam. So let's plug in the values. At point 0, the shear is V0 equals to, we have the value of the shear, the equation of the shear is 6 minus 2 multiplied by 0. So we have got V0 equals to 6 kilonewton. So at point 0 we have got 6 kilonewton. Now at point 3 it equals to 6 minus 2 multiplied by 3. In this case V3 equals to 0. So since this is a first degree function, this is the midpoint of the diagram. It is a linear graph. So now at point 6 it equals to 6 minus 2 multiplied by 6. Now in V6 equals to minus 6. So this is the minus 6. So again we have a subtraction at this point. It becomes 0 at here. And now for moment at point 0, we have the equation as x squared minus x squared plus 6x equals to minus 0 squared plus 6 multiplied by 0, which equals to 0. So at point 0 we have 0 moment. Now at point 3 we have minus 3 squared plus 6 multiplied by 3, which equals to now minus plus 9. So this is a second order function, so it needs to be a parabola. So this is the midpoint. Now at point 6 equals to minus 6 squared plus 6 multiplied by 6 equals to 0. So at point 6 it is again 0, and since it is a parabola shape, it needs to be the same as the previous segment. So this is to be 0. So this is the area under the moment diagram. and this is the area under the shear diagram. Another simple way is just to derive the shear, the moment equation, and you will get the shear, or just integrate the shear one and you will get the moment. Thank you for watching.